Okay, so we said we would record the electric fields practice problems. And I'm going to work 1 through 8. All right, number 1 says that we have an electric field of 260,000 newtons per coulomb. And that it points due west at a certain spot. So if that's my spot right there, I know that I'm going to try to put a charge of negative 7 microcoulombs in there. And I want to know what is the force and what is the direction. Well, E is equal to F over Q, or E times Q would be equal to F. E was 260,000. Q was 7.0 times 10 to the minus 6. So if I did the math correctly and I multiplied, I would get 1.82 newtons. Now I haven't done anything about the direction yet. If you look at that electric field, it's pointing to the west. So that means there must be some negative charges over here and some positive charges over here, because the electric fields go away from positives and toward negatives. This was a negative charge. If I try to put it in this region, it's going to be repelled by these negatives over here and attracted by these positives over here. So it's going to be pulled to the right. And that one was that simple. Okay, let's go to number 2. Number 2 says 2 charges are placed on the x-axis. Q1 is equal to Q2, and they're both 8.5 times 10 to the minus 6 coulombs, and they're both positive. And we have R1 is 3 centimeters, or 0.03 meters, and R2 is 9 centimeters, or 0.09 meters. Part A says at the origin, I want the electric field here to be 0. No, is that true? Let me see. No, at x equals 0, what is the electric field? Okay. Well, I have this one here, and this one here. That's Q1. That's Q2. Now, at the origin, which is right here, I have two electric fields. I have them generated by positive charges. Electric fields always go away from positives. That's E1. This would be E2. So hopefully you can see they're in the same direction. So the electric field at the origin is simply going to be E1 plus E2. All right, I'm going to calculate E1. KQ over R squared. 9 times 10 to the 9th. Q is 8.5 times 10 to the minus 6 coulombs. And my R has a value of 0.03 meters. Don't forget to square it. So if I do that correctly, I got E1 when I did it to be 8.5 times 10 to the 7th. And it points to the left. E2 is going to be KQ over R squared. K is 9 times 10 to the 9th. Q is 8.5 microcoulombs again. And this time the distance from Q2 to the origin is 9 centimeters, or 0.09 meters. I want to square that. And when I do, I get 9.44 times 10 to the 6th newtons per coulomb. Now I want E at the origin. So I'm simply going to add E1 plus E2. So 8.5 times 10 to the 7th newtons per coulomb plus 9.44 times 10 to the 6th newtons per coulomb. They're both in the same direction, so I add them. So E at the origin is going to be 9.44 times 10 to the 7th newtons per coulomb, and it's going to be headed in that direction. There's part A. Part B says, well, now look at it. Here's Q1. Here's Q2. What is E right there in the middle? So E1 doesn't change because it's still 3 centimeters from here to here. So it's going to stay 8.5 times 10 to the 7th. And it's going to point away from the positive. So it's going to point in that direction. E2 is going to be identical because now I'm 3 centimeters away. And it's going to point in that direction. So 8.5 times 10 to the 7th newtons per coulomb. And then I'm going to add those up. But I'm really subtracting them because they're in opposite directions. So I get 0 newtons per coulomb as my electric field at 6 centimeters. Okay, let's look at number 3. I'm going to change ink colors. Let's go to that one right there. Okay, so number 3 says two charges, negative 16 and positive 4, are fixed in place. Negative 16, positive 4. They are fixed in place 3 meters apart. And I want to know, where can I get an electric field that is 0? Okay, well, let's look at the electric field. It goes away from positives toward negatives. So I could call that E1 and that one E2. But regardless of what I call them, you can see anywhere in between these two charges, the electric field will never be 0 because they're both going to just add up and give you a large value. So then I'm going to check over to here and check over here. Well, I'm going to do this one first. If I do this one first, the electric field due to the negative 16 is going to be in that direction. The electric field due to the positive 4 is going to be in that direction. And you can see, since the negative 16 is closer to my point of interest, I'll always have a large negative value and a very small positive value, so it'll never be 0 over here on the left-hand side. So I'm going to get rid of that. Now I'm going to come over here, and I'm going to check out what's going on over here. Electric field here goes away from the positive and toward the negative, so they could cancel out. And I'm going to see if I can find a point where this value is going to be large enough to get rid of that value there. So I said, well, E1, which is negative, plus E2 has to add up to 0, or E1 and E2 are equal to each other. So I would say K, 4 microcoulombs over X distance squared, because from here out to this point of interest I'll call X, is equal to K, 16 microcoulombs over 3 meters plus X squared. Because how far is it from here over to here? Well, 3 meters and then X more. K's will cancel, which makes me happy. Microcoulombs will cancel, which makes me happy. 4 will reduce this to 4. So now I have 1 over X squared is equal to 4 over 3 plus X squared. So cross multiply 4X squared is equal to, well, 3 plus X squared is 9 plus 6X plus X squared. So 0 is equal to 9 plus 6X plus X squared minus 4X squared, or negative 3X squared plus 6x plus 9. So my values for A is a negative 3. For B, it's a positive 6. And for C, it is 9. And I know that is what I need to use for the quadratic. Oops. Kind of messed up there, didn't I? Okay, so I'm going to use the quadratic. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 6 plus or minus the square root of 6, 6 squared minus 4, negative 3 times 9 all over 2 times negative 3 is a negative 6. So I'm going to do negative 6 plus, okay, the square root thing is going to be 36 minus, okay, 4 times a negative 3, negative 4 times negative 3 is a negative 12. Negative 12 times a positive 9 is going to be, I'm sorry, negative 4 times negative 3 is a positive 12. 12 times 9 is 108 over negative 6. So that's going to be negative 6 plus 12 over negative 6. And so in that case, x is going to equal 3. Sorry, x is going to be a 1. And then I'm going to do it with negative 6 minus, and we already know that's a 12, all over negative 6, so x is going to be 3 there. Now, this is a negative 1 meter right there. The reason I know that's not going to work is because if you go back up here to this diagram, if x is negative 1, then I'm going to go here, because I want it relative to the positive charge. I'm going to go back a negative meter, 1 meter, and that puts me in between them, and I know that can't work. So my other choice is x is a positive 3, so I'm going to go out this way, a positive 3. So that's the best answer. So at x is positive 3 meters, there will be no electric field there. Okay, then it says in part B, what would be the force on a charge of positive 14 microcoulombs placed at this point? Well, if E is 0 at that point, which it is, that's just what we proved, there will be no force. Because there is no field, there is no force.